Hi guys, our next topic is all about searching algorithms. I'm going to be giving you some examples of such. So, searching algorithms are very popular in computer science. This is one of the most used application of algorithms. So, a very simple search algorithm is called linear search. So, it's quite simple. Uh, we're going to be using a certain example right now to give you an idea of linear search. Okay, so let's say I have a list which is 2, 4, 1, 7, and 9. Let's apply linear search in numbers. Although some applications of linear search, we could actually use this in words or in letters, but that will be for later. For now, since we have this set of numbers, we're going to be searching for something. Okay, our target will be the number 7. So the algorithm will try to look into the list and find number 7. So linear search is a very somewhat tedious algorithm to use because we're going to be actually scanning all the numbers to try to find the target. So how will it work? Since the target is 7, we're going to be comparing 7 to that of the first number of on the list, which is number 2. So since they do not match, the algorithm dictates that you have to move to the next position. So since no match has been found, we're going to compare 7 with that of 4. Okay? Again, no match has been found. So again, you just have to repeatedly apply the algorithm. Repeating steps in an algorithm, we call that recursive. Okay? Applying it recursively. So applying it recursively, we're going to have to compare 7 and 1. Again, no match has been found. Eventually, just move on. We then compare the next number, which is actually identical to the target, which is 7. So this will actually spell out success for the algorithm, meaning to say we can now stop with what we're doing because the target has been found. Okay? This will eventually conclude that the algorithm has successfully searched for the number. So that is linear searching. Okay, as you can see, it's very time consuming because if we have hundreds or numbers given here, we will have to scan all of them. And the worst case scenario could definitely happen that the target that we're looking for is not even on the list, right? So really, you really have to employ all those steps to be able to find the target and hope for the best that the target is actually on the list. So guys, that's what we call linear search. Another searching algorithm that I would like to give you is the binary search algorithm. Okay, this is quite different from the first one on leaps and bounds actually. So the binary search algorithm has one requirement though. Okay, notice that the first example on linear search, the numbers that were given were actually not in a specific order. Okay, but when it comes to binary search algorithm, you will have, or it requires that the list should be sorted. So sometimes algorithms are like that. It will have to somewhat conform to the specifics on the list. So, in our example, you just refer to your copies, okay, on example 3. We're going to be searching for the number 19 on the list. So, what does the binary search algorithm do? The good thing about having it sorted is that we could easily search for the number. The algorithm dictates that we have, in order to find the number that we're looking for, we will keep on dividing the list into equal sets. Okay, so in here we have the given, as you can see, and there are 16 terms. So the algorithm will be splitting the list into two and then try to find where the target is located. Okay, our target again is 19. So right now we were able to split the list into two, 16 terms, so there are 8 terms equally divided. Okay, what we do is on the first list that has been given out, okay, we're going to be comparing the largest number to that of our target. So 19 and 10 will then be compared. As we can see that 19 is greater than 10, we could probably conclude that we do not need this list anymore because probably 19 will be on the second set, right? Since the list has been arranged accordingly, that will give us the idea that 19 will never be on those sets of numbers included here, which gives us an idea now that 19 could probably be on this side. Okay? So that will narrow our search, not like the linear one in which we will have to go through everything. Okay? So what happens? We're now going to be focusing on the second set. So recursively, again, we're going to apply the algorithm. We're going to split the list into two, having these two divisions now. Okay, same thing. We're going to be comparing. We will always target the first list. Compare your target to that of the largest number on the first list. So 19 is still greater than 16. That's why we will be disregarding this set already, and we're going to be focusing on the new one. Splitting the list further into two, we only have two elements. We are going to be comparing again our target, which is 19, to that of the first. And as you can see, we were able to determine that 19 is actually on this set because they are actually equal. Okay, but since algorithms has to continue with the steps, since there are still two on the list, we will still split this one into two to be able to find that 19 is actually on the list. Okay, so that is how we perform binary search. Comparing binary search with that of linear search, what can we say? Obviously, we could determine that, or we could say that binary search is far greater or far more useful than the linear one. But of course, it entails that the list should be sorted. So again, algorithms, they have advantages and disadvantages over each other. And sometimes it's up to the one who is using the algorithm, which one he prefers uh, to be used in solving his problems.